So my dear student, today I am going to discuss the rest questions which is not discussed earlier. So question number 9, what does one mean by exothermic and endothermic reaction? Give examples. Actually, I have already mentioned about the exothermic and endothermic reactions. uh, I will repeat it again. Exothermic reaction means the reaction in which heat is emitted, and endothermic reactions are those in which heat is or energy is absorbed. So exothermic examples for exothermic reactions are mainly the combination reactions, generally exothermic, and you may write any of the combination reaction as the examples for exothermic reactions. And for endothermic reactions, you may give the examples which is discussed in your textbook, that is reaction between barium hydroxide and ammonium chloride. Okay, this reaction is already discussed, so you may write the exothermic and endothermic reaction from your textbook. Next, question number 10, why is respiration considered an exothermic reaction? Explain. So respiration is considered as an exothermic reaction because you see in respiration, complex carbohydrates of food particles decompose to form simpler products. Glucose is the simpler products. So what's happened, these glucose molecules are later oxidized by oxygen in the cell, in which it releases energy. For every oxidation of glucose as mole, it releases about 36 ATP molecules. That is, for per molecules of glucose in oxidation we get 36 numbers of ATP molecules and about 686 kilocalorie energy. That is why respiration is considered as exothermic reaction. So you may write this stanza for the answer of the question, where it was asked that why the exothermic respiration is also considered as a exothermic reaction. So you see here I have mentioned about the 686 kilocalorie, but what's happened, this energy is later changed to about 252 kilocalorie. That is, ATP means adenosine triphosphates. So phosphate molecules are bounded with the ATP. So in this process, 686 kilocalorie energy is converted to 252 kilocalorie. So the resultant energy is 252 calorie, because to bind the phosphate polyatomic ions in the ATP, what's happened, it requires about more energy, for which we get only 252. Okay, 252 kilocalorie. But you may write this also, because this is the resultant and this is the main energy which is released from 1 mole of glucose. Okay, so you may write this from your you may write this in your answer. Next, question number 11, why are decompositional reactions called the opposite of combinational reaction? Write equation for these reactions. Actually, in decompositional reactions, what happens, one reactant is decomposed to form many products. Remember it. Next, in case of combinational reaction, what happens, two reactants combine to forms one or more product. Okay, in decomposition it is decomposed to form one reactant, decomposed to form many products, but in combination reaction two or more or two elements meets each other or reactant meets each other to form one or more products. That is why this is reversal to each other. Okay, next you see, write one equation each for decomposition reactions where energy is supplied in the form of heat, light and electricity. So in your textbook you get the reaction decomposition by heat, light and electricity. So first reaction was decomposition. In decomposition reaction, the first reaction was decomposition of ferrous sulfate by heat. Then by the sunlight, silver chloride and silver bromide was decomposed, which reactions is also used for the black and white photography. Next, electricity. Whenever hydrolysis of water is done, then what happened? Water in the water molecules, hydrogen and oxygen is separated to form hydrogen and oxygen gas. So these are the equations. You may write it. See, decomposition reaction by heat, that is ferrous sulfate. Whenever it is heated, the color of the ferrous sulfate is green. Okay, it is solid as, so it forms ferric oxide, which is also solid, that is it will precipitate. Next, sulfur dioxide and sulfur dioxide, this is gas. So whenever ferrous sulfate is heated, green ferrous sulfate is heated, it forms ferric oxide, sulfur dioxide and sulfur trioxide. Okay, so next, decomposition reaction by light. Here it is sunlight. So when silver chloride or silver bromide are exposed to sunlight, then it will form silver and chlorine. Okay, this is decomposition reaction by light. Next, decomposition by electricity. So whenever through water we pass electricity, then the water molecules will decompose to form hydrogen positively charged and oxygen negatively charged. So both will be in the form of gas. Okay, next question. What is the difference between displacement and double displacement reactions? Write equation for these equations. Actually, in case of displacement reactions, we have already studied about displacement and double displacement. Again, I would like to remind you. So see here, displacement. In the displacement reaction, what's happened? A more reactive element displace another less reactive element from its compound, like copper sulfate plus iron, which will displace copper as iron is more reactive. Next, in case of double displacement reactions, what's happened? The first of all, the compound will get ionized, and then the ionic exchange take place. That is, interchanging of ions between the reactant is take place, which is not available in the double displacement reactions. Okay, again, number two, in displacement reactions, more there is a mention of relative reactivity of element, but in double displacement reaction, no necessary or no consideration of relative reactivity of elements. Okay, so this is the basic difference between displacement and double displacement. You may write the answer hearing my voice. Next, in the refining of silver, the recovery of silver from silver nitrate solution involve displacement by copper metal. Write down the reaction involved. You see, in the refining of silver means to get the silver, to extract the silver from its ore. Okay, silver has ore, silver sulfide, that is argentite. So you see, from silver nitrate, if it is silver nitrate, then we have to remove the nitrate part, right? Nitrate, NO3, polyatomic ions, then we can get the silver. That is why the solutions of silver nitrate reacts with their copper metals. So copper will displace the silver. You know, copper is more reactive than silver. That is why copper will replace or displace the silver from its compound, and silver will be freed. And by that way, we can collect the silver. Okay. So the reaction involved in this question is, you see, silver nitrate plus copper. Okay, so copper is more reactive than silver. That is why the copper can displace copper can displace silver from its compound, and thus the silver get freed. Okay, forming copper nitrate and silver. So here the valency of copper is 2. That is why we write Cu1A2 whole bracket 2. That is silver nitrate Ag1O3 plus copper, then it will form copper nitrate plus silver. So we get the silver as free. Okay, so next question. What do you mean by precipitation reaction? Explain by giving examples. So precipitation reactions, you know about the double displacement reaction, in which one of the product is precipitated, which is insoluble in water. So I have already give you the list for soluble and insoluble substances. So you just remind that table and you can easily know which product will precipitate from the solutions. So what do you mean by a precipitation reaction? So answer will be the double displacement reaction is also known as precipitation reaction because one of the product from the reaction is precipitate. That is why it is called precipitation reaction. Explain by giving examples. So there are so many examples in your textbook. You can write any of the examples from your textbook. Okay. Next, question number 16. Explain the following in terms of gain or loss of oxygen with two examples is oxidation and reductions. Okay, oxidations. What happens in case of oxidation? Oxygen, if any element gets oxygen or lose hydrogen, then it will be oxidations, and the reverse process of oxidation will be reduction. Okay, if any element lose oxygen or get hydrogen, will be reductions. So there are so many examples in your textbook, then you can write the examples for each from your textbook. That is copper oxide plus, there are one common example, that is copper oxide. When hydrogen gas is passes over it by giving enough heat, then it will form copper plus water. Okay, so what's happen? Copper oxide get reduced by losing oxygen, and hydrogen get oxidized by getting oxygen from copper oxide. So this can be the examples for oxidation and reduction both. Okay, next, a sunny brown colored element X on heating in air becomes black in color. Name the element X and the black colored compound found. Actually, this is the first activity for oxidation and reduction reaction, that is activity number 1.11. okay, we already discussed about this reaction. See here, the oxidation and reduction activity 1.11. In this activity, what's been heated cyanide is containing about 1 gram of copper powder. So whenever copper powder is heated, what's been, it will form copper oxide, that is cupric oxide, because the valency of copper is 2, which is the highest valency for copper. Okay, so copper is brown. Whenever it is heated, it forms copper oxide or copper 2 oxide or cupric oxide. So you may write this equation by the following way. So here A shiny brown substance was copper, and black colored compound was copper 2 oxide. Here I write copper and between copper and oxide it is 2, copper 2 oxide, that is CuO. So reaction would be copper which is brown. Okay, so whenever it is heated, so anything which is heated or burned will get oxygen and will form copper 2 oxide or cupric oxide. So this is a compound, the color of which is black, right? Black color compound, copper oxide, which was earlier brown. Whenever it is heated, then due to the oxidation it will turn into black color. Okay, this is the equation for the question number 7. Next, question number 18. Why do we apply paint on iron articles? Actually, to prevent the oxidations, we apply paint on iron articles. So what happens whenever oxidation occurs? The iron transfer to iron turn into Fe2O3. Okay, this is the chemical symbol for rusting. So when rusting occurs, what happens? The iron decreases its size by losing layer. Right? Ferric oxide layer is removed out from the surface of the iron. That is why its shape is being decreased. This phenomenon is called rusting of iron. Okay, so why do we apply paint in iron articles? To prevent the oxidation. Does it also prevent the corrosion of iron? So the main causes will be to prevent the or slow down the oxidation of iron article, and thus it will prevent also corrosion of the iron. Okay, remember the sentence I have told you and write it as answer in your copy. So oil and fat containing food terms are flushed with nitrogen. Why? So this is to slow down the rancidity. Okay, to slow down the rancidity, we should flush with nitrogen gas. That is, chips and such type of food particles are whenever packed, then what happen? Nitrogen gas are entered into the packet so that the food items becomes good for several days. Okay, next, explain the following terms, which one example is, that is corrosion and rancidity. So I have told you about the corrosion and rancidity in the earlier classes, so remind that classes and you may write it easily. Okay, so thanks for today. I hope you will give the answers immediately in my WhatsApp, and after that I will start the next chapter. So I would like to hereby request you again to give me the syllabus for which will be set in your PT1 in that chapter, in the exams, the chapters which is to be set. I would like to know, because in the next class I will start the chapters which will be set in your PT1. Okay, thanks, have a good day.